Okay, guys, so this lesson we're gonna look at phasor and simple harmonic motion equations. Okay, all right, so um, okay, so you have copied down the notes. The notes might be a bit confusing because there are actually two different ways of teaching this topic. I used to use my old way to teach the topic, and then recently I've changed it to this new way. So you see, like the notes I made with my iPad, the one got all those coloring and stuff like that. So that's the new way of teaching it. It's actually a lot easier, and the old way is a little bit harder. Okay, all right. So basically, long story short, is what we know is first simple harmonic motion definition is acceleration is proportional to negative y, right? It's proportional to y and acts in the negative direction. And then over here, the proportionality, what is the proportionality? The proportionality is omega. So we have this squared. So we have this equation is A equals to negative omega squared. And that is defining simple harmonic motion, okay? Okay, and then we're gonna look at the phasor. So how does the phasor work? So phasor is a rotating vector. Okay, so let's say we use bouncing spring as an example, okay? So let's say this spring is gonna be bouncing. Let's say right now it's at equilibrium. It can go up to here, and then it can go down to here. And then we draw a circle. That's my reference circle. Okay, and when we start timing over here, let's say timing starts at equilibrium. If the timing starts equilibrium, and then that's when the phasor of y, of displacement, is going to be over here. Because that's the reference circle. When it starts to go up, this moves up to here, and then coming down, coming back up, like that, right? So timing starts from here, okay. And then according to our equation over here, acceleration is in the opposite direction as y, okay? So what I'm gonna do is I'm gonna draw another circle representing the acceleration. Let's say acceleration is a bit smaller because the radius represents the size. So right now, the acceleration will actually be over here. This is the acceleration phasor. So once it rotates up, is a displacement going positive displacement, positive displacement, positive displacement. The acceleration will actually become negative because when it go up, acceleration is going to go downwards. Okay, so when this one rotate upwards, this one is actually rotate downward. So these two are exactly 90 degrees out of phase. Okay, and then if you say we draw another one, that is velocity. Let's say this is the size of velocity. Okay, so I can draw another velocity phasor. Velocity is going to be ahead of y, 90 degrees. So what happens is when this is zero, right now it's zero, velocity is actually reaching maximum value going upwards. So velocity right now is maximum value going upwards, right? Acceleration is zero, and y equal to 0 at this moment. And then y, so they say we rotate 90 degrees, this y reaching the top, y reaching the top, that's when acceleration is maximum going downwards. And then the speed becomes 0. When it's reaching the top, speed is 0. Okay, so, and I quickly just draw it. Well, so this is this situation over here when we started timing. When it's at the top over here, say, not worry about the circle. Say when it's at the top, so y has become maximum, y. And then acceleration become maximum going downwards. And the speed has become 0 going sideways like that. So this thing just rotates, okay. All right, and then if you want to draw a diagram, like that, time, okay. And this could be y, it could be acceleration, it could be v, okay. So right now, y is over here at 0. So, and then y starts going to go up, it's going to start have a positive value, and reaching the top, and then coming down, reaching the bottom, and y is going to be like this, okay? So that's why we have this equation. This is a sine graph, the y equals to a sine omega t. Okay, this equation is going to be given to you. You just need to be able to pick it. Okay, exactly y is the omega t, y is the sine. So we have another diagram. That was the original way I was teaching. So we don't really need that anymore. It is more confusing for the student. So now I've decided just to teach how to choose the equation. This equation shows sine because when timing is 0, the y is 0. So when it starts 0, it's sine. Okay. All right. And then say, well, if we talk about velocity, right now velocity is actually at the top, at the maximum position. Maximum position, velocity coming down to here, and then reaching the bottom position here. Say coming to here, here. Okay, you can see, well, this is going to be my velocity. Velocity, then this is a cosine graph. So we know velocity equals to a omega cosine omega t. Okay? And then the last one is acceleration. Say acceleration right now is at 0, right? And acceleration start to go negative. And then it's going to reach negative over here because this acceleration is going to be opposite to y. Okay, and then it's going to reach this value here, reaching this value over here, and then acceleration is going to come down here. Okay, so let's say, what is acceleration? This is also a sine graph, but it's a negative.
In mechanics, acceleration is the rate of change of velocity of an object with respect to time.
Okay, Siri is trying to teach me about acceleration. Okay, so over here, acceleration is going to equal to negative a omega squared sine omega t. Okay, so that is this one. Okay, so if you learned about differentiation, hold on, is it differentiation? Or yeah, differentiation. If you learn this differentiation, the displacement you differentiate, it will become your speed. The speed differentiate, it will become acceleration. If you can differentiate this thing, it will become this. If you differentiate this thing, it will become this. Okay. So, but if you don't learn, if you are not learning calculus about this, don't worry about it. Okay. So, but these three equations will be given to you, and its timing starts from equilibrium because of this. And the same method apply for when timing starts from the end position, okay? Except that we're not going to be using these three equations. With same thing, we draw the graph, we will find out, well, it's actually going to be have another set of equation. So y going to be equal to, okay, anyway, so these are timing start from equilibrium, okay? And then the other one is y going to equal to a cosine omega t. And then v is going to be negative a omega sine omega t. And then a is going to equal to negative a omega squared cosine omega t. Okay, so what is phasor diagram? This is called phasor diagram because it's a rotating vector. Based on phasor diagram, we can find out what does happen to the change. And then according to the change, we know which equation we can pick according to whether it's a sine graph or cosine graph. Okay, yeah. So the other one I've already drawn it to you in the notes, so you can just have a look. Basically, exactly the same thing. You can try to draw it. You say, well, where do I draw the phasor? When timing starts here or timing starts here? Okay, and then they say this. How do we use this? Oh yeah, when time starts from here, it's gonna bounce like that, and then 3 seconds later, you put it in here or put it in here, and then you'll get the answer. Okay. All right. So one other thing over here is when you look at over here, we have another concept that's very important. Is sometimes the question will ask you, say, maximum acceleration or maximum speed. Okay, how do you calculate maximum acceleration? Let's have a look. So this is sine. For displacement, the biggest sine can get is 1. Okay, because sine goes from 1 to negative 1. Okay, if sine the biggest is 1, and then the biggest y is just going to be the amplitude. So the biggest displacement is the amplitude. Okay, and we apply the same rule to over here. Well, this cosine goes from 1 to negative 1. That's how big cosine can be, right? So the biggest over here is going to be 1. So the biggest speed is just going to equal to a omega. So sometimes they will ask you, say, what calculate the maximum speed? The maximum speed is just a omega. Okay, and then maximum acceleration over here you have acceleration. This number can be as big as 1, okay, and that's the biggest. So the maximum acceleration is just going to be this part. So it's going to be a omega squared, okay, and the negative is showing the direction, so we can ignore it. So the size is going to be a omega squared, and that's the biggest, okay. All right, so that's all I have to teach about the equations. So basically 3 equations here, a set, a graph, and then three more equations, another set of graphs. That's in your notes, okay? All right, so now what I'm gonna do is I'm gonna make another video explain one of these questions and how that works, okay? All right, see you in the next video.